Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, Tifr, Jest, IIT-Jam exam and other exams related to physical science. Okay, so guys, this is the eighth part of this series of CSIR NET Physics PYQs June 2019. Okay, so so we are solving questions of CSIR NET June 2019 physics paper. Okay, so before starting the class, I would request the people who haven't subscribed my channel yet, please subscribe my channel and watch my lectures which are going to help you to crack the exams related to physical science. Okay, so I'm going to start now. It is the eighth part of the series of CSIR NET uh, Physics PYQ of June 2019 paper. Okay, so I'll start with the first question. Meanwhile, let me just check whether I'm audible or not. Okay, I'm just checking and then I'll proceed further. So I'm going to start. Absolutely. So yeah, I'm audible. Of CSIR NET uh, Physics PYQ. Okay, so I'm going to start now. The first question is, this is the eighth part of the series. Okay, eighth lecture of the series, you can say. So question number one is, the elastic scattering, the elastic scattering the elastic scattering of a charged particle of a charged particle of mass m of mass m of an atom can be approximated can be approximated can be approximated by the potential VR equal to alpha upon r e to the power minus small r upon capital R, where alpha and capital R alpha and capital R are positive constants are positive are positive constants if the wave number if the wave number if the wave number of the incoming particle of the incoming particle incoming particle incoming particle is k and the scattering angle is and the scattering and the scattering angle is 2 theta, the differential cross section differential cross section differential cross section in the Born approximation in the Born approximation Born approximation is options are option number A is m square alpha square r to the power 4 4 h cut to the power 4 1 plus k cube r square sin theta option B is option B is m square alpha square r to the power 4 m square alpha square r to the power 4 upon h cut to the power 4 2k square 2k square r square sin square theta whole square to the power 2 okay. Option C is 2m square alpha square r to the power 4 2m square alpha square r to the power 4 upon 4 h cut to the power 4 into 1 plus k cube r to the r square sin square theta okay. And option D is 4m square alpha square 4m square alpha square r to the power 4 upon h cut to the power 4 into 1 plus 4k square r square sin square theta whole square okay. So this is the question. The question is the elastic scattering of a charged particle of mass m okay. Elastic scattering of a charged particle of mass m of an atom can be approximated, right? So that charged particle is scattered from the atom okay, can be approximated by potential which is given Vr equal to alpha upon r e to the power minus uh, small r upon capital R, where alpha and r are positive constants okay. If the wave number of the incoming particle is k okay, and the wave number of incoming particle is given, the scattering angle also given, that is 2 theta, the differential cross section in the Born approximation, that's what you need to find out okay. So very good question, and we can easily calculate it okay. So first we'll write whatever given okay. So we have been given the potential given, right? That is PR, potential is given, and that is alpha upon r e to the power minus small r upon capital R okay. So this is the potential which is given. Now we need to find differential cross section. So first we will find f, which is function of theta, right? We are going to find that, and this is a very important formula in bond approximation. Many questions you will get from this formula, right? You need to note down and memorize it and practice questions using this formula. Okay, so very important formula. F theta is minus 2m upon uh, 2m upon h cut square q. Okay, integration 0 to infinity for this case. Okay, 0 to infinity r vr, which is from vr, where v is function of r. Okay, and then sine qr dr. Okay, so very important if potential is in the form of a function of r. Okay, like vr. So this is a very important formula you need to note down. Okay, here q, the value is q is k sine theta by 2. Okay, and theta is given here, that is, theta is a scattering angle, right? Here theta is given, the scattering angle is 2 theta, so we'll write instead of in place of theta, we can write, because theta is given, so we can write theta dash by 2. So it is going to be q equal to 2 sine 2 theta upon 2, right? So this is going to be 2 sine theta, q equal to 2 sine theta. Okay, sorry, this is k sine theta, my apologies. So it is k sine 2 theta by 2, that is k sine theta. Okay, so this is the value of, where k is the wave vector of incident radiation. Okay, or incident radiation, or we can say incident incoming particle. Okay, that wave. Okay, so very now I will solve this using this formula. Okay, and also we have got value of q, that is k sine theta. Okay, and this is the f theta, right? When we know the f theta, after that we'll find d theta, d which is function of theta, that is differential cross section, right? Which we need to find differential cross section in bond approximation. This becomes equal to f theta, f which is function of theta mod square. Okay, so we'll put value of f theta here, right, and we'll get the differential cross section. Okay, so I'm going to proceed now. Okay, so well, so it is going to be, so we'll find f theta, f which is function of theta. Okay, so f which is function of theta, f function of theta is going to be equal to, that is going to be minus 2m upon h cut square q, right? Integration 0 to infinity, r value will be r, and value of vr we will put, that is alpha upon r e to the power minus r upon r. Okay, then sine qr dr. Okay, r will get cancelled. Okay, so this is going to be minus 2m h cut square q integration 0 to infinite, 0 to infinity, alpha will take outside, so e to the power minus small r upon capital R sine qr. Okay, dr. So we can easily solve this integration by Laplace function, right? So this is minus r upon r. There's a formula you need to note down, guys. Okay, this is very important formula for solving such questions. Integration 0 to infinity. Okay, uh, e to the power minus sx fx dx, right? So here sin x, right? Sine qr, and this formula, this is going to be 1 upon s square plus q square, sorry, q upon, this is qr, okay, q upon s square plus s square. So this formula you need to note down. So we'll use this formula here, directly we'll find out. So minus 2m upon h cut square q alpha into, this value is going to be from this formula, q upon sine qr, right, q upon this is s square plus q square, right. So s square, the value of s is here 1 upon r, okay, 1 upon r, right, here s. So this is 1 upon capital R, so this is going to be 1 upon r square plus uh, q square, okay. So this is the value, and okay, so this is the value from this formula we have found, okay. Very important formula, we can easily solve it by Laplace equation, okay, Laplace transform. So this is the one, so this is going to be this one. So will q and q will get cancelled, okay. So this value is going to be f theta, f which is function of theta is going to be minus 2 m alpha upon h cut square, this is h cut square, right, yeah, h cut square into 1 plus r square plus q square, okay, r square plus q square, okay. Here we have done some mistake actually. So this is this q equal to 2k sine theta, okay, 2k sine theta by 2, so this is 2k sine theta, okay, this one 2k. So now what we'll do, we have got the value of f, right. So now we'll find differential cross section, that is d, which is function of theta, right. This is going to be mod square of f theta, f which is function of theta, right. So here we'll put the value. So this is going to be 4m square alpha square, okay, upon h cut square into 1 upon r square plus q square, right. And q, value of q we know, so we can put this value. So 4m square alpha square upon h cut square 1 upon r square, okay, plus value of q square 2k sine theta, right, 2k, so whole square is going to be that is, so this whole square, okay. So this is going to be this whole square, and this is going to be h cut to the power 4, okay. So this is going to be r square plus q square equal to 2k sine theta, right. So 4k square sine square theta to the power whole, right, whole square, right. So we'll simplify it now, then it is going to be 4m square alpha square r square, right. We'll take LCM here, right, r square, okay, upon h cut square, sorry, h cut to the power 4, h cut to the power 4 plus 1 plus 4 r square k square sine square sine square theta to the whole square, right. So this is the answer, guys, okay. So d theta, that is d which is function of theta, that is differential cross section, okay. So which option is matching? Let me check. Option D is matching, right. 4m square alpha square r4, it's r4, let me just check, r, this should be r4, yes, Yes, R4. It's R4 option. Okay, so this is R4 because this is whole square, right? R square and then square. This is R to the power 4. R4 and h cut square into this one. H cut is 1 plus 4 k square r square sin square theta whole square. K square r square, this right, sin square theta whole. So this is the correct answer, guys. Okay, next question. Very good question, guys. Okay, question number 2. Question number 2. Okay, question number 2 is this is also good. This question is from quantum mechanics. Okay, Born approximation chapter. And next question is from solid state physics, condensed matter physics. Okay, very good question. This chapter is also I have already taught in quantum mechanics as well. This chapter is in quantum mechanics also. So this is a quantum mechanics question you can consider. Okay. So question is the wave number the wave number k and angular frequency omega and angular frequency omega of a wave are related by wave are related by of wave are related by this are related by dispersion relation by the dispersion relation that is omega square equal to alpha k plus beta k cube where alpha and beta are alpha and beta are positive constants the wave number for which the phase velocity equals to the group velocity. The phase velocity equals to group velocity. Group velocity is okay. Options are 3 root alpha upon beta. Okay. Option B is root. These are questions from part C, guys. Okay. Alpha upon beta, root alpha upon beta. Option C is 1 upon 2 root alpha upon beta, and option D is 1 upon 3 root alpha upon beta. Okay, so these are the options. So we have been given the wave number k and angular frequency omega of a wave of a wave are related by the dispersion relation, that is, my apology, dispersion relation by omega square equal to alpha k plus beta k cube, right? So we need to find out the wave number for which the velocity, group velocity, is equal to phase velocity. Okay, so I'll solve it. Okay, so we have been given, that is, omega square equal to alpha k plus beta k cube, right? So from here we can differentiate it with respect to k. So this is going to be 2 omega d omega upon dk, 2 omega d omega upon dk. This is going to be alpha plus 3 beta k square. Okay, and from here, this is 1. From here you can write d omega upon dk is alpha plus 3 beta k square, this is alpha, guys, okay, upon 2 omega. This is equation number 1. And also we can write like this, okay. Since omega square equal to this, equation 1, we can say this is equation 2. Okay, so we can write this like this: omega upon k and divide by k, right? This is going to be, we'll divide by k, so this is going to be alpha plus beta k square, right? From here omega upon k is going to be okay, leave it as it is. Okay, so this is the equation number 3rd. Now since we have been given the group velocity d omega upon dk equal to omega upon k, right? This implies d omega upon dk upon omega upon k, that value is going to be 1, right? So because these are equal, so we'll take in numerator, so this value is going to be 1. So equation number 4. So now what we are going to do, we are going to divide 2 by 3. Okay, so equation 2 by 3, so this is going to be d omega, this is going to be d omega upon dk upon omega upon k into omega, right? This one 2 by 3. Okay, so this is going to be alpha plus 3 equal to alpha plus 3 beta k square upon 2 omega upon this value, omega upon k value, right? This one, this value, alpha upon beta k square, alpha plus beta k square, okay. So this value is going to be 1, so an omega will go here, right? So omega and omega will get cancelled. Okay, and so this value is going to be like 2 equal to alpha plus 3 beta k square upon alpha plus beta k square. Okay, cross multiplication, we'll do cross multiplication, so this is going to be 2 alpha plus 2 beta k square is alpha plus 3 beta k square. Okay, so now we'll take this side, right? So this is going to be alpha equal to beta k square, right? This implies value of k equal to root alpha upon beta, right? This is the answer. So which option is matching? Option number B is matching, I believe. Let me check. Option B is matching. Okay, root alpha upon beta. Okay, well, this is the question, very simple question, and this is for 5 marks question, guys. Okay, next, There are some questions which are very lengthy here in part 6. Okay, this question is easy. Next question. Next question is, this is from electrodynamics, guys. Okay. Well, question number 3rd. Question number 3rd is, the inertial observer A, or inertial observer, inertial observer, inertial observer, inertial observer A at rest measures the electric and magnetic field, the electric and magnetic field, E equal to alpha comma 0 comma 0, and B equal to, that is magnetic field, B equal to alpha comma 0 comma 2 alpha. Okay, 2 alpha in a region, in a region. In a region. Where A is constant, where alpha is constant actually. Where alpha is constant, another inertial observer, another inertial observer B, moving with constant velocity, moving with constant velocity, with respect to A, measures the field as E dash equal to Ex dash comma alpha comma 0, and B dash equal to alpha comma By dash comma alpha. Then in units C equal to 1, Ex dash and By dash are given are given respectively by, okay, options are given. Option number A, minus 2 alpha, minus 2 alpha, comma, alpha and alpha. Okay. Option B is 2 alpha, 2 alpha, 2 alpha and minus alpha. Option C is alpha and minus 2 alpha, minus 2 alpha, and option D is minus alpha, minus alpha and 2 alpha, minus alpha and 2 alpha, minus alpha and 2 alpha. Okay, so this is the question. Okay, so the question is very simple question. Inertial observer A, so there is a inertial observer A which is at rest. Okay, measures the electric and magnetic field E equal to alpha 0 0 and B equal to alpha 0 to alpha. Okay, in a region where alpha is a constant. Another inertial observer B moving with constant velocity with respect to A. Okay, that observer is moving with respect to A, measures this the same field as E dash equal to Ex dash alpha 0 and B dash equal to alpha By dash alpha. Okay, this in units C equal to 1. Ex dash and By dash are given respectively, so you need to find out Ex dash and By dash. Okay, very good question. I'm going to solve it. Okay, so here there is a this we need to know. Okay, I'm writing this. So we know this E dot B. Okay, E dot B is invariant and E square minus B square is invariant. Okay, invariant. Okay, so this we know. So E dot B and is invariant and E square minus B square is invariant. Okay, with this we are going to solve it. Okay, so we'll find first E dot B. Okay, E dot B. So this is going to be this one. E dot B equal to E dash dot B dash. Okay, so this is going to be E dot B is net. So this is E dot B invariant, right? It means E dot B equal to E dash dot B dash. Okay, so we'll write this. E dot B is going to be uh, this one, E dot B, that is alpha square, right? Alpha square, this is going to be 0, right? Alpha square. E dot B is alpha square equal to E dash dot B dash, right? So here this will multiply this one, E D dash. So this is going to be E dash X alpha plus alpha B dash Y, right? So this is going to be E dash X alpha, E dash X alpha plus B dash alpha, okay. So alpha is going to get cancelled, so this is going to be Ex dash plus By. Okay, B dash Y is going to be alpha. Okay, this is equation number 1. Similarly, we'll find this one, E square minus B square equal to E dash square minus B dash square, right? Because these two are invariant, guys. Okay, so invariant means the value of this and the value of this will be equal. Similarly, this will be equal. Okay, so first we will find E square right here. From here, E square is going to be alpha square, right? Alpha square minus B square. B square is going to be this one, right? Alpha square plus 4 alpha square, right? So alpha square plus 4 alpha square. Okay. Similarly, E dash E dash square or B dash square is going to be this one. This one. Okay. So this is going to be, just wait, guys. I'm just checking. Okay. So this one is going to be E dash square, right? E dash square is this, right? This one. So E dash square plus alpha square, right? So this is going to be Ex dash square plus alpha square. Okay, so we'll solve it. So this is going to give value, that is Ex square. There is something missing, I believe. Plus alpha square and then plus that is minus bx square, right? So this is going to be minus b dash y square plus alpha square, okay, for by, this one. Okay, alpha square plus b dash y square plus alpha square, right? So we'll solve it. So this is going to be, after solving, this is going to be ex dash square minus by dash square is going to be 3 alpha minus 3 alpha square. Okay, this is equation number 3. Or this we can write like that, ex a square minus b square, right? A plus b, a minus b. So ex dash plus by dash into ex dash minus by dash equal to minus 3 alpha square, we can write. And ex dash plus by dash we have already found in equation this one, right? This is alpha. So this is going to be alpha into ex dash minus by dash equal to minus 3 alpha. Alpha will get cancelled. So ex dash minus by dash is going to be minus 3 alpha. This is equation number 5. If we solve equation 5 and equation 1, so we'll get value of ex dash, and this is going to be minus alpha, and value of b dash y, okay, and this is going to be 2 alpha. Okay, 2 alpha. Okay, so this is the answer. So which option are matching? Let me check. Which option is matching? Let me check. Minus alpha and 2 alpha. Okay, so this is minus alpha minus alpha minus 2 alpha minus alpha 2 alpha, right? minus alpha to alpha. So minus alpha to alpha. Option D is the correct one, guys. Okay, option D. Next question, guys. Very simple question, right? So here, what concept we have used? We have used that E dot B and E square minus B square are invariant. Okay, and then we solved it. Next question, guys. Question number 4. Question number 4. This is also a good question, guys. It's question from Doppler effect. Okay. Question is, a point charge a point charge is moving point charge is moving with uniform velocity uniform velocity beta c is the speed of light, okay, along the positive x direction, along the positive x direction parallel to and very close to very close to a corrugated metal sheet see the figure below, okay, see the figure below. I'll make a figure, okay. See the figure below, this one. Okay, the figure is like this. This is straight line, okay. This distance is L, this distance is L. Okay, so there is a wave, okay, and this is the particle, okay, which is moving and which is very close to, so it's very close and parallel to this corrugated metal sheet, okay, very close. You're not able to see it, but it's very close, okay. And this is metal sheet, okay, metal sheet. Okay, so this is this particle is very close to it, okay. So what do you need to find out? The wavelength of electromagnetic radiation received by the observer along the direction of motion, okay. So the wavelength of electromagnetic wave, EM wave, received by an observer along the direction of motion, is, okay. So well, okay, options are, option number A is 1 upon beta root 1 minus beta square, okay. Option B is L into root 1 minus beta square. Option C is L beta root 1 minus beta square. Okay, and option D is L. So this is the question. Okay, so I'll read the question. So this is a point charge is moving with uniform velocity beta c along the positive x direction parallel to and very close to the metal sheet. Okay, it is parallel and very close to the metal sheet. Okay, this is metal sheet. Okay, this is metal sheet very close to parallel and very close to, and this is the length. Okay, L. Okay, and the wavelength of the radiation, the wavelength of electromagnetic radiation or wave received by the observer is, okay, received by the observer is, okay. Just give me 1 minute, guys. Okay, some issue. Okay, let's sort it. Next. Okay, so I'm going to solve now. And so this is an electromagnetic wave or wavelength of electromagnetic wave or radiation received by the observer along the direction of motion. Okay, along this direction we need to find out. So very good question. So from the figure we can do it like this. From figures, yeah. From the figure, this is lambda naught is equal to L. Okay, and now from Doppler effect, Doppler effect, this is and that wave is electromagnetic wave is moving towards the observer, right? So value of lambda is going to be lambda naught, that is L root 1 minus beta, that is beta, right? 1 minus beta upon 1 plus beta into root 1 minus beta upon 1 plus beta. Okay, we'll solve it. So lambda is going to be L into this is 1 plus beta. Okay, this is going to be root 1 minus beta square, right? And this is going to be 1 plus beta. This will get multiplied, right? And here we can see, since 1 plus beta is almost equal to beta, because beta is very big value, right? So in that case 1 plus beta almost equal to beta. Okay, so in that case lambda is going to be L into root 1 minus beta square, and we can write into upon beta, right? Okay, okay, so if the Newton if the if the if the Newton-Raphson if the Newton-Raphson RAPHSON if the Newton-Raphson method is used to find the positive root of the equation x equal to 2 sine x. Okay, the iteration equation is the iteration the iteration equations. Okay, so that you want to find out. Option number A is xn plus 1 equal to 2nx 2xn minus 2 sin xn plus xn 1 minus 2 cos xn. Okay, option B is n plus 1 equal to 2 sin xn minus cos n cos xn cos xn upon 1 minus 2 cos xn 2 cos xn. Okay, option C is xn square minus 1 plus 2 cos xn minus xn sin on xn minus 2 sin xn. Okay, and option D is xn plus 1. So this value is xn plus 1 is xn square minus 1 minus 2 cos xn plus sin xn upon xn minus 2 sin xn. Okay, so we'll solve it. Very easy question. So it is going to be so we know the formula, right? It is fx is given that is x minus sin 2 sin x. Okay, so from here f dash x is going to be 1 minus cos 2x 1 minus 2 cos x, right? So we know xn plus 1 is going to be this is xn minus fx at x equal to upon f dash x at x equal to xn, right? So x plus n is going to be xn minus xn minus 2 sin xn upon 1 minus 2 cos xn. Okay, now we'll simplify it. So xn plus 1 is going to be x1 plus this is going to be, we'll simplify it. So very simple, right? You can easily simplify it by taking LCM, and the answer is going to be 2 sin xn minus xn cos xn x upon 1 minus 2 cos xn. Okay, so this is the answer, guys. And which option is matching? Let's see. Option number B is matching, guys. Okay, this one, option B, 2 sin xn minus xn upon 1 minus cos xn. Okay, so this is the one. Okay guys, so guys, before ending the class, I would like to request everyone or the students who haven't subscribed my channel yet, please subscribe my channel and